For our second problem set, we are going to be looking at the loads that are placed on the floor system we just calculated. In your reading assignment for the week, you read Chapter 3 of your building construction text that talks about the different types of loads. What we need to know for this system is that we have a 40 pound per square foot live load and a 10 pound per square foot dead load for a total of 50 pounds per square foot that we need to account for and make sure that our floor system is designed to support. To think about loads and the transfer of loads can usually cause students some trouble, but it's not that difficult if you just think about a simple beam that is supported on either end, whether it's resting on a support or nailed into the side, resting in a joist hanger. Somehow each end is supported. We can use what we call tributary area. The concept of tributary area, again, students can find difficult, but if we look at our simple supported beam, we know that we can divide this in half, and half of the load will be supported on this end, and half of the load will be supported on the other end. As long as we have regular spacing and consistent loads, we can do this and make the proper assumption that it is split evenly. So depending on the type of loads, whatever it might be that are resting on top of that structure, we need to add them up and then take half of it, if it goes across the entire thing, and apply it then to our point of reference where we are actually going to be supporting, whether it is underneath or on the side, it does not matter. So if we are looking at our floor system, we have these individual tail joists that we are looking at calculating for. And it's a matter of transferring the load through the structure, down through the floor system, down to the foundation system. So we start off with the entire square footage of the floor system. And if we're looking at this one joist, tail joist, we know that it will cover a certain portion or support a certain portion of our floor system. The load will be transferred to this double header, will then be transferred to the double common joist on the side of the stair, transferred to the beam, then transferred down into the foundation system through either the post or the foundation wall, depending on where the load is traveling. So our concept of tributary area is looking at just this simple tail joist. Before we get that, if we look at our problem set for number 16, we're simply looking for a quantity. We're looking at our tail joists for our single joist hangers. We need to know how many we have. Single joist meaning there's only one coming into it. Anytime we have our joist meeting the foundation, it means it's going to be resting on the foundation wall, and we do not need to worry about having joist hangers. Same with our beam as well. So the only place we're going to have single joist hangers are where our tail joists meet our header joists. So we simply have 1, 2, 3, 4 single joist hangers. To look at the load that is on those, if we're looking at our maximum load, what we can support maximum in our foundation system, even though it's not drawn to scale, we see that we have 4-foot tail joist and we have 2-foot tail joist. 4 foot is longer than 2 foot or larger than 2 foot, so it's simply choosing the larger number and knowing that if we design a joist hanger to carry the support of the 4-foot tail joist, it will also then be able to carry the load from the 2-foot tail joist. So we simply choose the larger number and we can focus on these tail joists rather than doing 2 separate calculations. So if we have our 4-foot tail joist that we're looking at, we can look at this one right here, and we know that this joist will support half the distance to the common joist on the other side and half the distance to the other tail joist on its other side. So this area for half the distance each way and the full length of it, we have an area that this tail joist has to support. So we can calculate that by taking our spacing, our 16-inch spacing that is for our joist, converting it into feet, because if we go half the distance to one way, it's 8 inches, half to the other, 8 inches total back to the 16-inch spacing. We multiply it by the 50 pounds per square foot. That is our total load. The units, PSF, also is pound over square foot. So if we have a foot, once it's converted, times a pound per square foot, we are left with 66.6 repeating pounds per square foot. Sorry, pounds per lineal foot. Another way of writing that is PLF, pound per lineal foot. So we know that along that 4 foot, every foot of that is supporting approximately 67 pounds. So we can easily take 67 times 4 and find out the total load in pounds that is on this joist hanger. But we don't necessarily want to do that right off the bat, because this single joist is not supporting the entire 4 feet. Per our drawing up here, it's only supporting half of that 4 foot dimension. The other half is resting on our foundation. So if we have a 4 foot tail joist, and we divide it by 2 because it only supports half the load, we know that we only have 2 feet of our foundation or our floor system that is resting on that single joist hanger. So we can take that 2 feet multiplied by our 67 roughly pounds per lineal foot and 133.3 repeating, or we can list it as 134 pounds on a single joist hanger. We also have our quantity for our double joist hanger. So if we look at our double joist hangers, we see that again, it does not occur where it meets the foundation. It will rest on the foundation wall. It only occurs where it meets another joist member. So we simply have 2 double joist hangers to support our double headers. So to determine then the load that each one of these is carrying, we can visually look at it and see that we just calculated that each one of these single joist hangers is carrying roughly 134 pounds. So if we add 134 and 134, we have 268 pounds that is on this entire double header. And just like on our beam before, where half of it goes to the foundation, half of it goes to the double joist hanger, we can do this in math and see what those actual numbers are. So if we have, for number 19, our 133.33 pounds that is on our single joist hangers, and we have 2 of them on that double header, we have 266.66 pounds that is on our double header. So that is the load on the double header. And as I said, we take that load, we divide it by 2. Half of it goes to the foundation wall, half of it goes to the double joist hanger, and it is 133.33, so 134 pounds. It is coincidence only that our double joist hanger load is the same as our single joist hanger load. And it is simple math that says we have 2 singles on a beam that is split, then so you can roughly think of it as this tail joist is going directly to this double header and this tail joist is going directly to the foundation wall. If we have any number other than 2 tail joists, if we have 1, if we have 3, 4, 10, 20, however many there are, if we have any number other than 2, the numbers for the single joist hanger and the double joist hanger will not match. So be careful that you don't make the assumption that simply because our numbers were both 134 pounds, it will not always be the case. And that concludes the sample problem for our floor system.